Train Test Split in Python, a beginner's guide. Welcome. Today you will learn how to split data for machine learning. We will practice using simple examples and a real dataset. By the end, you will be ready to split data like a pro. Running the cell now. Sometimes, Python shows warnings that are not errors. To keep things simple, let us silence them here. We are writing a comment to explain what this cell does. We import warnings, a tool for controlling warning messages. We tell Python to ignore all warnings in this lesson. Running the cell now. Try running this cell before others to prevent clutter. Why split data? Machine learning models need to learn and to be tested. Splitting data helps you check if your model can really predict new things. You train on one part and test on another. Running the cell now. Before working with data, let us import our main tools. Pandas helps us work with tables. Train Test Split is a helper for splitting. We use a comment to note this is a setup cell. We import pandas for managing tabular data. We import train_test_split from a library called scikit-learn, usually used for machine learning. Running the cell now. These imports will be used throughout the lesson. Example, to simple list split. Let us try splitting a tiny list before we use real data. This will help you see what splitting is all about. Running the cell now. Let us create a list of numbers as a sample. This list will be easy to split and understand. We are adding a comment so we remember this step. This line uses range to make numbers from 0 to 9. We print the list so you can see all the numbers. Running the cell now. Try changing the range and seeing what happens. Now we use train_test_split for our list. The train data will have most items. The test data will have the rest. Random_state makes sure our result stays the same each time. This comment describes the next action, which is splitting. We split our list. Test_size 0.3 means 30% for testing. We print the list for training. We print the list for testing. Running the cell now. Notice how data is split randomly. Try changing test_size. That is it. Splitting data works for all kinds of data, not just lists. Next, let us use a real-world dataset, the Titanic passengers. Running the cell now. Now we load a real dataset about Titanic passengers. We fetch the data from a web link. Shape tells how many rows and columns we have. Head shows some sample data. This is a comment showing what we will do. We write the location of the file as a link. We open the data with pandas and call it df. This prints out the size of our data, rows, and columns. This shows the first few lines, so we get a sneak peek. Running the cell now. Try printing more rows or using .tail to see the end. Passenger survival is the main thing we predict. Value_count shows how many survived and how many did not. A comment explains that this is about the target column. This line counts the ones and zeros in survived. Running the cell now. You can also plot value count sideways with .plot.bar. Most machine learning uses features and a label. Features are data used for prediction. Label is what we want to predict. Let us separate features from labels. This comment says what we are doing here. We make a new table X with all columns except survived. We keep survived alone as Y, our label to predict. Running the cell now. Try printing x.head and y.head to check their shape. Now it is time for the real split. We will keep 20% of the data for testing. Random state makes our split repeatable. Running the cell now. Let us use train_test_split on a real table. We keep 20% for testing, 80% for learning. Random_state helps us get the same split every time. Shapes show how big each set is. We write a comment for the splitting step. This line splits both features and labels at the same time. We print the shape for training features. We print the shape for test features. Running the cell now. Change the test_size and watch the split adjust. Balance in labels is important. This checks the % survived in each split. Use normalize equals true to see percentages. We start with a comment so we know this checks balance. We label the train part. We print the survival rates as decimals for the train split. We label the test part. We print the same kind of rates for the test split. Running the cell now. If ratios look very different, try running the split again. Now you get to pick the test size. Input asks you for a number, like 0.25 for 25%. We add a comment for this interactive split. Input asks you how big the test set should be as a decimal. This splits the data based on your choice. We print how many items are in each part. Running the cell now. Try 0.1 for a small test set, or 0.5 for a big test chunk. What happens if you enter 0 or 1? Practice prompt, change the random state number. See if your splits change. Try different numbers and compare train and test shapes. Running the cell now. Here is a quick puzzle. We run train_test_split 2 times with no random state. We check if both splits match. A comment tells us this is a challenge step. We split the data with 30% for testing and no random state. We split it again the same way. We show if the two splits are exactly the same. Running the cell now. Try this a few times and see the result. This shows the best way to split, set a random state. Now the result will always match if the random state is the same. This comment explains the tip shown. We split one time setting random state to 99. We split again with the same number. This shows split results are now identical. Running the cell now. Use a random state in your projects for trust and sharing. Sometimes, your target is rare or uneven. Stratified splits help keep the balance in each part. Let us try stratified splitting here. This comment notes one reason to split differently. We import a stratified splitter. We set up the splitter for one split at 20% test size. This for loop gives us the raw indexes for train and test. We get the features for the training group. We get the target values for train and test. We print out label frequencies for stratified train set. We print the label frequencies for the test set. We check if the labels are balanced. We do the same for test data. Running the cell now. Try this if you have rare targets in your own data. Order in data can affect your results. Shuffling mixes up the order before you split. We comment to explain this tip about shuffling. This line shuffles every row using sample with frac of 1. The head shows some shuffled examples. Running the cell now. You can shuffle any data frame with .sample. Mini project, predicting Titanic survival. Let us use everything you learned so far. In this part, we will prepare the data, split into train and test sets, print out the shapes, show target distribution. You are ready to practice. Running the cell now. A real-world dataset sometimes has missing info. We will keep only rows that have an age for now. This comment explains the cleaning step. We use dropner to remove passengers with missing age. We print how many rows we have after cleaning. Running the cell now. Try dropping by another column to see what changes. We want features and the outcome just like before. Let us remake X and Y for this clean data. This comment says we are splitting features and labels again. We drop survived to get features. We keep survived only for the label. Running the cell now. Check X_mini columns with X_mini dot columns. Let us split this new clean data. We will keep 30% for testing. We also print how many survived in each group. We comment that this is the splitting and stats cell. We call train_test_split with 30% testing and random state set to 7. Parenthesis continues the split. Parenthesis ends the command. Here, we print both train and test group size. We print the percent who survived in the train set and test set. Running the cell now. Now you have run a full split and checked your label balance. Challenge: try it with a different dataset. Can you split the data from another famous dataset? Try the Iris dataset from scikit-learn for practice. Running the cell now. Recap. You learned why and how to split data. You tried on lists and real tables. Using train_test_split is the first step for model testing. Keep trying more datasets for better skills. Running the cell now. If you found this helpful, please like and subscribe. Try out a split now for practice. What project will you split data for next? Running the cell now. Great job! Like and subscribe to see more Python lessons.